Hey there! Welcome to this deep dive into GKE AI ML, Google's brand new opinionated path for running AI on Kubernetes. If you have ever stitched together GPU drivers, Helm charts, and inference servers by hand, you are going to love what we are about to explore. Grab a coffee and let us get oriented. Here is the roadmap for our session. First, we will cover the core concepts, so you understand exactly how GKE AI ML differs from the regular Kubernetes engine you already know. Next, we will tour the 6 lenses of the console, from overview through diagnostics. Then we will decode the magic AI GKE.io label that powers everything. After that, we will master the performance vocabulary, TTFT, NTPOT, and ISL/OSL. We will also walk through picking the right accelerators and reading cost per million tokens. And finally, we will trace the practical workflow that takes you from idea to a running model. By the end, you will be comfortable navigating this brand new console. Quick heads up before we dive in. The GCP screenshots you will see throughout this video are simulated. They are crafted to mimic the real GKE menus and panels as closely as possible so you can learn the layout. Use them to build your mental map, but always cross-reference with the live GKE console for the most up-to-date interface, because Google ships UI updates faster than we can record videos. Let us start with a refresher. Plain old GKE is Google's managed Kubernetes service. It comes in 2 flavors: standard mode, where you manage your node pools, and autopilot, where Google manages everything for you. It is wonderfully general purpose. You can run web apps, microservices, batch jobs, anything containerized. AI workloads do work on regular GKE, but you have to wire everything yourself, and that is exactly the pain point we are going to solve. Imagine you are an engineer who just wants to serve a Llama model. On vanilla Kubernetes, you are signing up for a full weekend of yak shaving. You install the NVIDIA drivers, you wrestle the GPU operator, you pick an inference server like VLLM or TGI, you wire up Helm charts, you set up an autoscaler that understands tokens, not CPU, you configure workload identity for model storage, and then you spend hours Googling benchmarks to figure out whether an L4 or an A100 is the right call. That is the pain, and GKE AI ML exists to take all of it off your plate. Enter GKE AI ML, the opinionated path. The deal is beautifully simple. You pick 3 things: a model, an inference engine, and an accelerator. GKE then wires up the labels, drivers, autoscalers, and routing for you. Everything ends up in a single console where you can see your inference workloads, your training jobs, your benchmark results, and your health checks side by side. It is the same Kubernetes you know, but with the boring boilerplate handled for you. Here they are side by side. Regular GKE is general purpose. Kubernetes, you install drivers, pick servers, roll your own benchmarks, and debug missing operators on your own. GKE AI ML is opinionated for AI. Drivers are wired automatically. Engines like VLLM, TGI, and Triton are curated. Performance profiles are validated by Google. And Run Diagnostics is 1 click away. Same control plane underneath, completely different developer experience on top. Now, here is the secret sauce that makes the whole console work. Every AI workload carries a special label called AI/GKE.io/model. That label is the magic string that decides whether a pod shows up in the Models tab or stays invisible as a regular pod. Jobs use AI.GKE.io/job for fine-tuning and batch tracking. The labels travel with deployments, stateful sets, and jobs, so they survive scaling and rollouts. And the cool part, you can hand-label your existing workloads to retrofit them into the AI ML console. No migration needed. GKE AI ML organizes everything into 6 lenses. Overview gives you counters and a getting started checklist. Models lists every serving workload. Jobs covers fine-tuning, batch, and evaluation runs. Performance is the benchmark catalog with cost and latency numbers. Solutions hosts end-to-end blueprints you can copy. And Diagnostics runs automated health checks for the things that always break, like GPU drivers and workload identity bindings. Let us now actually open the console and see them in action. All right, let us actually open this thing. In the Google Cloud Console, head over to Kubernetes Engine. In the left rail, right next to clusters, you will see a new entry called AI/ML. That is your front door. Google pins this for you in new projects, so you do not even have to hunt for it. Click it, and you land on the Overview tab. The Overview tab is the default landing page and your dashboard. At the top, you get 4 counters: how many models, jobs, blueprints, and diagnostics you have running. Below that lies a 5-step Get Started checklist that walks new users through enabling APIs, creating a cluster, and deploying their first model. Quick action buttons let you jump straight into deploying or running a job without hunting through tabs. Click Models. This is where every workload tagged with the AI GKE.io/model label shows up, basically your inference catalog. Each row shows the cluster, namespace, replica count, accelerator type, and a status pill: green for healthy, amber for degraded, gray for pending. Click into a row and you see the engine, the container image, and the routing path. It is the single pane of glass for everything you are serving. Let us zoom in on the labeling magic, because this is what makes everything tick. You add AI.GKE.io/model equals, say, Llama 3.8b to your deployment, and GKE picks it up and registers it as a model in the console. You add AI.GKE.io/engine equals VLLM to declare which inference server you are using. You add AI.GKE.io/accelerator equals L4 to surface the hardware. 3 labels, and you get full visibility. No new operator to install, no CRD to apply, just labels that the console already understands. On to jobs. This tab is for fine-tuning runs, evaluation jobs, and batch inference workloads. The columns show cluster, namespace, the queue if you are using QA for scheduling, and a status indicator. Each row also gives you a one-click Run Diagnostics shortcut, which is a lifesaver when your fine-tune is mysteriously stuck in pending. And the best part, these are just regular Kubernetes jobs underneath. No new resource type to learn, just labels and a friendly view. 3 job archetypes you will run constantly. Fine-tuning takes a base model and adapts it on your data, like teaching Llama to speak in your company's voice. Evaluation scores a model against benchmarks like MMLU or human eval, so you can compare versions. Batch inference processes large datasets offline, perfect for tagging 1 million product images overnight. All 3 use the same job machinery and show up in the same tab. Now here is my favorite tab, Performance Profiles. This is the benchmark catalog Google ships and validates for you. Each profile is a tuple of model, accelerator, and use case. So you might see Llama 3.8b on an L4 for chat, or Mixtral on an H100 for code completion. Each card shows the cost per million tokens, the time to first token, and sustained throughput. Use it before you deploy, not after. It is the difference between picking the right GPU on day 1 and crying about your bill on day 30. Let us read a profile card together. The use case shows ISL/OSL, that is input sequence length over output sequence length. So 133 over 127 is a chat-style workload with about 133 tokens in, 127 out. Cost per million tokens is split into input and output, because output is typically 3 to 5 times more expensive, since each output token requires its own forward pass. Throughput is sustained tokens per second across all replicas. NTPOT, the normalized time per output token, tells you how snappy streaming feels. Lower is faster. And TTFT, time to first token, is the visible lag before any streaming begins. Quick rule of thumb on these metrics: a TTFT under 500 milliseconds feels instant to a human in a chat UI. An NTPOT under 50 milliseconds keeps the streaming text feeling like a person typing fast, instead of a model that pauses awkwardly between words. Throughput matters most when you are doing batch or code completion, where total tokens per second beats latency. So if you are building an interactive product, optimize for TTFT. If you are building a nightly batch job, optimize for throughput. Read the cards with that lens, and you will pick the right profile in seconds. Solutions is your treasure chest of pre-built recipes. Each blueprint is an end-to-end stack: RAG with Llama, multimodal serving with Pixtral, a fine-tuned pipeline with QLoRa. One click and the YAML, the Helm chart, and the routing all install for you. Heads up, you will see a banner here. Blueprints are moving to a separate site called GKE AI Labs over time. But for now, this is the perfect starting point when you are staring at a blank page wondering how to begin. Run Diagnostics is the panic button you will be glad you have. You pick a target, a cluster, a model, or a job, and GKE runs an automated suite of checks. Are the GPU drivers installed correctly? Is workload identity binding the right service account? Is your network policy blocking the inference gateway? Each check comes back with pass, warn, or fail, and the fixed links jump you straight to the offending resource. It saves so much time compared to grepping through Kubernetes logs at midnight. And finally, the plus deploy models button. Sitting at the top right of the page, no matter which tab you are on, it is the fastest path from I want to serve a model to a running deployment. You pick the model, you pick the engine, you pick the accelerator, and the wizard generates the manifest for you with the correct AI GKE.io labels already applied. 3 clicks, and you are live. Here is the workflow tied together. Step 1. Browse performance profiles and pick one that matches your latency budget. Step 2. Click plus deploy models with that profile pre-selected. Step 3. Watch your new workload pop up under models with green status. Step 4. If anything looks off, click Run Diagnostics and let GKE tell you exactly what is wrong. The whole loop happens in the same console. No jumping into Kubernetes, no opening Cloud Shell, no spelunking in YAML. A quick guide to picking accelerators. L4 GPUs are the workhorse for chat workloads under 13 billion parameters, great cost to performance. A100s shine on larger models or heavy batch jobs. H100s are top of the line, lowest latency, highest throughput, but the priciest option. Save them for tight latency budgets. And TPU v5e is Google's secret weapon for cost-efficient inference, especially when you can fit your model into its memory layout. The golden rule: always benchmark on your specific input-output sequence length pattern, because chat looks nothing like batch summarization. Let us demystify cost per million tokens. Input tokens are cheap. The model processes them in a single forward pass per request. Output tokens are expensive. Every single token requires its own forward pass. So output ends up roughly 3 to 5 times more expensive than input. To compare profiles fairly, take your real token mix, say 200 input to 500 output, and multiply each side by the per million number. That gives you the true cost per request. Then compare to a managed API like Vertex or Bedrock to make the build versus buy call with real numbers, not vibes. When you click Run Diagnostics, here are the most common findings you will see. Missing GPU drivers on the node pool, usually because the cluster was created before GPU support was enabled. Workload identity bindings pointing at the wrong service account, which silently breaks model storage. Network policies blocking the inference gateway, which causes mysterious 503s, image pull failures from a private artifact registry, almost always an IAM problem. And insufficient quota for the requested accelerator, which is exactly as fun as it sounds. The diagnostics tool catches all of these in seconds. GKE AI ML is not an island. Cloud storage is where your model weights and datasets live. Artifact registry hosts your container images for VLLM, TGI, or your custom engines. BigQuery is the natural home for feature stores and analytics. Vertex AI handles managed training, the model registry, and evaluation pipelines that you can chain into GKE deployments. And cloud logging plus monitoring give you the same observability stack you already use everywhere else. No new dashboards to learn. A handful of best practices to take with you. Always start from a performance profile, not a guess based on a forum post. Pin your engine version, never track the latest tag, because VLLM ships changes that can quietly tank your throughput. Use QUE for fair sharing when multiple teams hit the same cluster. Run diagnostics before you open a support case. You will solve 8 out of 10 issues yourself. And if you retrofit existing workloads with the labels, be consistent. Half-labeled deployments are confusing in the console. Last conceptual question: when do you actually pick GKE AI ML? Reach for it when you need full Kubernetes control. Reach for it when you run multiple models on shared GPUs. Reach for it when you operate GKE clusters today. Or reach for it when you want custom engines and sidecars. Now flip to the right side. Reach for Vertex AI when you want a pure managed experience with less ops. Reach for Cloud Run when your tiny models can scale to 0 between requests. Reach for either when you want absolutely no node pool to manage. And reach for either when your team is new to containers and Kubernetes feels heavy. There is no wrong answer, just the right tool for your team's appetite. Let us recap. GKE AI ML is the opinionated AI path on Kubernetes. 6 tabs cover the whole inference and training lifecycle. The AI GKE.io labels are the connective tissue that makes everything queryable. Performance profiles save you weeks of benchmarking by handing you Google-validated numbers. And the Diagnostics tab turns those midnight debugging sessions into a single click. You now have the mental model to drop into the console and start moving. And that is a wrap. Thanks so much for spending this time with me. This course was curated by Omar Hosni. If you enjoyed it, subscribe for more cloud deep dives, and find me on LinkedIn and X. Questions and feedback are always welcome. Now go forth, deploy a model, and let GKE AI ML do the boring parts for you. Catch you in the next one.